All right, Internet. So we've gotten into a habit when it comes to using AI. And when I talk about AI, I'm talking about ChatGPT and Claude and other variants of that. Things that are not reasoning models like O1, O3, and DeepSeek. And the habit we've built is very fast and repetitive and kind of iterative in nature, where I send a small text to the model, I then get a response, and I go back and forth in a quick fashion, which is very useful for these types of models. But when we take this same habit and we try to apply it to these new reasoning models, the outputs are really, slightly below average. They're pretty bad. And this is happening because we're taking habits that work in one world and we're trying to apply it to a different world. And that actually doesn't match up well. So there's two analogies we can use here. One is messaging, the other one is hiring. So for messaging, currently we think about things as text. So we're rushing to text back and forth with these AIs. But instead of doing that, we should think about it as an email. So I want to craft a well-structured email that I'm going to send via my inbox to another inbox. That's going to usually resonate more with a reasoning model. And if we take this other analogy of hiring, when you hire somebody into your company, you onboard them, you want to make sure that when you're onboarding them, you're giving them as much context as possible so they know exactly what to do and when to do it. Now, today what I want to do is I want to walk you through a template, a structure that we can use when interacting with these reasoning-based models. And this template is something I've taken from a blog post that I'm going to share with you. And you can see it's here from Latent Space. So this blog post, I think, started out as a tweet or something else. And with that, they found that this specific pattern has worked very well for at least O1. Now we can try to extrapolate and apply this to other models such as O3 and DeepSeek, but you can see that the structure that I'm going to walk you through is actually going to help you get more effective responses from these reasoning models. Now, instead of walking you through this entire blog in text, I created some slides for you. And we'll start with this slide right here, which is talking through the template. So we can see there's a series of segments here of different sections of the prompt that we want to push to the reasoning models to get a higher quality output. Now we'll start from the top and work our way down. And the important thing I want to actually start out here, which I would have probably gotten to the end, but this seems overwhelming already, right? So we have 6 items here. And oftentimes when we interact with models today, it's quite straightforward. We send a simple question, a simple task, etc. And there's not necessarily as much structure or effort put behind it. The good thing is we can actually create these more systematic system prompts via AI. So we can have AI help us create these prompts that's then fed into other forms of AI to get better outputs from them. And I'll walk you through that process in a second. So let's look at this first one here as goals. So the first one is goals. So we have 1 to 2 sentences of the overall task of what we want the AI to do. Now, the important thing here is what. So oftentimes when we interact with older models, we tend to focus on how. And this comes out in different manifestations of saying, giving it a persona. So you're an expert writer and you prefer to write at a 5th grade reading level with sentences varying between short and medium. So we're giving very specifics on how that model should interact with the things we're giving it from a user. That's something that we do not want to do here. Instead, we want to focus on the what, and we want to be very descriptive of what we want it to do. And the reason we're focusing highly on the what is in the reasoning process, these models tend to bias towards a very specific how that they have for their approach. And we can find different ways around that, but the key here is actually focusing on the what and not the how. After this, we have the response format. Now, with these models, these reasoning models, especially O1 and O3, they tend to have a very specific structure. So they like to bring things out in a report format. So they have headers, subheaders, etc. So if we want to avoid that, and instead of getting the same format every time they are biased towards, we want to focus on asking it for a specific response format. So we could ask it to give us lists. We could ask it to give us the pros and cons of something. We can also ask us to give it code in a diff format. So this is something I've gotten from somebody else where they stated that in coding, it's very useful to actually have it provide you a diff instead of trying to replace the entire file. I tested myself this a few times myself, and I found that it actually is quite effective. So when you're putting this in, if you're doing coding, you want to actually ask it to give you a diff of the problem you're trying to solve instead of the entire file rewritten. Then next we have warnings. So here we have these are kind of like warnings, considerations, etc. Because when you look at system prompts that are crafted for existing models today that aren't reasoning, there tends to be a reminder at the bottom of many of the kind of well-crafted system prompts where it says, remember to do X, Y, and Z. This is kind of this section here, where there's problems that you've probably run into that are old problems from previous iterations of working with reasoning models that you want to bake into this. So it's you've done this 5 times, and you see in those 5 iterations, 4 iterations, you ran into 4 errors. You want to add some of those nuances and those considerations here so you can avoid those going forward. And the same thing applies for new problems. So if you're doing a new iteration of something and you're concerned about a certain type of output that shouldn't occur, you can add that here as well. So that's going to be our approach to the warning section. And then last, definitely not least, is context. So this is probably one of the most important sections for reasoning models. And the emphasis here I've put is on all. So how much ever context do you think you should provide the reasoning model in your system prompt or your initial message to it? You probably want to 2x that. And reason being is that these models, they tend to have higher quality outputs with more context based off of what you're trying to achieve, previous things you've done, et cetera, et cetera. And that can be overwhelming. You might not necessarily want to write everything out. So there's 2 things I want to mention here. So one is it should be a brain dump. And oftentimes what I use is voice memos. So you can do a voice memo on your iPhone, or you can do dictation through your Mac. I usually do dictation, honestly. It's the easiest for me. And I just speak out everything that I want it to understand. So if it's a coding problem I'm trying to solve, I'll give it all the nuances of things that I've tried to achieve, the current functionality, what I'm trying to get it to work as, and a bunch of other things associated to that problem. I then have that entire blob of text. I put that into the context section. And you might consider, oh, well, like, what if the words are misspelled, or you're saying the wrong word, et cetera, et cetera. Oftentimes it doesn't matter because these models can pick up what you're trying to intuit based off what you're saying, even if the text isn't perfect. That's why when people talk to AI, they tend to misspell a lot of things. And one other thing I'll mention here, which was quite interesting to me when I was reading through this blog post that I shared with you, is that the context section, the placement of where this is sometimes relevant. So when you're working with the GPT-based models, so O1, O3, etc., you actually want to have the context at the back half of your prompt. So the very bottom of your prompt, which is right here, because this section here we'll talk about in a second, which is kind of like meta points, but not necessarily the system prompt. So the system prompt is everything above, everything below is just meta points I want to share with you. So at the very bottom of your prompt, you want the context to be at the bottom half. And OpenAI actually documents this in their documentation. And I'll quickly show you what I'm talking about when I talk about that. Is in their documentation, OpenAI talks about caching. And in here, they emphasize the importance of actually having a static prompt at the top of your system prompt and a variable prompt at the bottom half of the prompt. And the reason they're doing that is because the way their caching works. So in this very basic diagram, you have your original prompt here, and then you have your cache, like a cache prompt that's going to work effectively, and one that's not. And the reason that is because we have all these shapes that are all identical, and you want to keep that static. And that static part, that part of the prompt that's going to be consistent, are going to be the items that we mentioned here. So that's going to be our goal. That's going to be our response format, our warning, etc. And the context of the things that's going to vary. So for OpenAI, context goes to the back half of your system prompt. For Claude, I've heard that it goes to the front. I've not tested these or AP tested these methodically, so I don't necessarily know that's true. But for caching purposes and also for the purposes of these reasoning models, you want to put the context at the back half of your system prompt. Okay, so we've gotten through all of this stuff. These next 2 items here, like I said, are kind of meta points that you want to incorporate throughout your system prompt. So there's no specific placement for these, but these are just good reminders. So the first one is separators, or other words, delimiters, but I use separators because delimiters is kind of a convoluted word. With OpenAI and Claude specifically, or GPT and Claude, they prefer different types of separators in the system prompt. And the purpose of these are to ensure that when the AI goes through your system prompt, it understands the dividing section between each group. So it knows where the goal sits, it knows where the response format sits, it knows where the warning sits, the context, etc. We want to separate these by different types of separators, such as Markdown or XML. So for OpenAI, for their O1 and O3 models, we want to use Markdown. And then for DeepSeek, I've actually seen that XML tags tend to work more effectively. And reason being, I had no idea why that's the case, but that's what I've seen. So that's the first part. And the next one here is chain of thought. So like I said, we're in habits right now. We all have habits that we use time and time again when interacting with these models, one of which is asking it to think step by step. We no longer need to do that for these reasoning models because it's already baked into how it operates. So we need to remove that habit from our process when we're interacting with reasoning-based models. Okay, and so this specifically is the format they showed inside of the blog post. And you'll see this probably all over X in different places if you're looking into reasoning and prompting associated to it. I won't necessarily go through this in detail. You can pause the video and read through it, but it's very similar to what I've just shown you here with Yeah, with just some additions at the bottom that I've added. So I definitely take a second to read this and understand how they're using this in the example and how you can apply that for yourself in future prompting. Okay, so next what I want to do is I want to show you two examples of how you can utilize these reasoning models for use case they tend to excel at. So the first one is coding, and the other one is a very specific approach to writing. So for the coding one, I want to walk you through the process of actually having AI write the system prompt for you. Because like I said previously, the system prompt itself is quite beefy. There's a lot of stuff there, and that can be intimidating for a lot of people. So we can use AI to create both the template, the structure, and also fill in the template for us based off the thing we're trying to achieve. And there's a video that I'll share and link in the description as well, and I'll highlight it really quick now. So Dan here actually has a video walking through this entire process and how his approach to this works. I'm going to kind of walk you through in a diagram format of how that works, but you can watch that video as well. So here we have the approach, right? So we have the template we had previously, so we can use the image to image template that I've shown you there, and you can feed that image into Claude or something else. And you basically ask Claude, hey, take this image and convert this to a structured markdown template that follows this approach to prompting reasoning models. So once we've done that, it'll create your template. And from that, you can actually ask it to fill it in based off the problems you're trying to solve. So in this case, say we're trying to solve a coding problem. And we have a lot of different things that we need to add into this markdown file. So instead of just having it ask it to fill it in, I'm going to ask it to fill it in with specific things. So first I'm going to say, hey, I want you to include the code snippets that are relevant to the error that I'm facing. So maybe there's a gnarly bug that we're trying to solve. So we want to do that. Next, we want to say, okay, I want you to call out file names associated to the error and the functionality associated to it. I want you to maybe, what else? We could do that. We could do errors. So we can say, okay, I want you to take the errors from the console log, it's really that E, the console log of the terminal, and I want you to feed that in there as well. And then maybe you include a voice memo. And this is something I would probably do as well, is I would kind of walk it through what we're trying to achieve, what we tried in the past, all that stuff, and I'd incorporate that as the base of the context at the very bottom of the system prompt. So once we've said all this stuff to our AI, it's then going to take this, it's going to bundle that in to our finished markdown file. We're going to have our structured template where it has everything that I've mentioned previously. So it has the goal, the format, the warning, etc. So we have this done and it's successful. Next, we want to feed that into O1. Once we fed it into O1 with that structured output, we're going to get a better response. And that's going to be you happy at the end of the day. So that's one example. The next one is for writing. So this example is from Swyx, and I'll share a quick snapshot of where I found this. So he mentions it inside of the blog, and then he gives it kind of a detailed breakdown below, and then some other stuff linked in his X account. Now, this is quite interesting, this approach, because what's happening here is that we're going to take a concept of, it's kind of like an evaluation approach or a reinforcement approach, and we're shoving that into the system prompt instead of doing it outside of it. And we're going to start here with two examples, and this example is for writing. So we're going to have O1 write on a specific topic for a certain length. So we'll say, write a page on X topic. So they write about that topic. Then we as a human, we're going to write about that topic as well separately from O1. We're then going to feed both of these files into O1. We're going to ask O1 to assess the writing samples of both, with the human write-up being the good version that we want to look like, and the O1 version being kind of the neutral version that we want to improve. In here, then once we feed it into there, it's going to critique itself, and it's going to critique the two writing pieces, and it's going to create a diff. So it's going to say, okay, the difference between the human one and the O1 one is here. So this is kind of the main differences between them. And these are the errors that we need to improve to make sure that our writing sample looks more like this one and less like this one. So once we've done that, we have our diff. We're going to shove that diff into the system prompt. And this is the really important piece, because this is where the eval piece comes in. So we're going to take this diff, we're going to shove it into the system prompt. And then what's happening here is quite interesting. So this is something that Swyx called out, which is in the eval space, when you're trying to evaluate outputs from an LLM, there's this concept called LLM as a judge. So instead of having a human judge the output from an LLM saying if it's good or bad, you can use another LLM to judge another LLM. So it's kind of like LLMs all the way down, where you have one judging the other. And if this one thinks the output's good or bad, it'll then let it pass. If not, it throws it away. We're doing the same here. So we're actually going to take that process and incorporate it into our system prompt with the diff so it can critique itself over time. And what do I mean by that? Well, when I send this over to O1, so I send the system prompt with the diff inside of it, I then state that it needs to write it needs to write in the way that I expect it to based off of the critiques in the system prompt. So what's going to happen is Owen's going to start writing again. When it starts writing, it's going to write about, say, the same topic. And this is a fresh session. So when we're writing, we're going to likely run into the first iteration. We're going to see this first iteration looks very similar to this one. So if they look the same, then we need to critique ourselves based off of the diff we've provided in there. So we're going to iterate here and say, okay, we didn't do great, so we need to try again. And it's going to go to the next one. And it's going to iterate again. It's going to say, okay, we've gotten a little better. Let's try again. And it's going to iterate on the reasoning structure inside of itself. It's going to reason through this process, critiquing the writing, until finally you get an output. And the output is so amazing that it looks like Harry Potter-like writing. Or maybe not, but still, it's going to be improved, right? It's going to be more in line with the type of writing that you would like to have in your piece. Now you might ask yourself, well, Dylan, didn't you just say earlier that we shouldn't focus on the how but the what when it comes to prompting these reasoning models? Very astute. Yes, I did. But this is one of those very kind of like outlier cases that I found that you can critique the how or change the how based off of this very kind of convoluted structure of the system prompt and having it critique itself in the reasoning process so it can get closer to the writing style that you prefer. So you can take this and try that and see if it works for you. And then finally, I just wanted to call out 3 use cases that I've personally found reasoning models that are quite good at, and I've enjoyed using them for. My first one here is bugs. So when I work within Cursor or Windsurf or whatever else, I might run into a gnarly bug where I have a recurring bug. So I have different tactics of how I can get around those bugs. One of which is having this structured prompt created by Cursor with Claude inside of Cursor. It'll create that structured prompt. I'll take that and I'll feed that into O1 and ask it try to solve the problem for me with providing the diff code back, so I can then copy and paste that into Cursor. And this has helped quite a few times when being approached by these really hard bugs. Next one is planning. So I have another video I've either posted or will post soon around creating a kind of a implementation plan that's very well thought through and methodical of ensuring that when we create an enterprise application with AI, we're doing it in a methodical and iterative fashion so we can actually build the application without running into too many errors and getting too off course with AI that kind of loses focus. And to do that, we need a really structured, well thought out plan. Well, what I'll first do is I'll create a first plan with, say, GPT-4o or Claude. I'll then feed that plan into O1 or O3, or maybe even now DeepSeek since that's available, or Gemini 2 Thinking. There's a bunch of them now. And once I fed that into that, then I can get out the file, the improved implementation plan, which I'll then feed that back into GPT-4o then to create a markdown file. And the reason I do that is because I found that these models kind of are bad at creating markdown files. They're getting better, but they're not consistent, which isn't great. So I have to sometimes feed it back into that to get the markdown file out. So once I've done all this, I then have a very well thought through plan that I can then push into Cursor that Claude can work through as we build out larger applications. And then the last one here are pros and cons. So oftentimes when I'm faced with a issue about either at work or personal life or whatever else, I like to think through pros and cons with a reasoning model because they tend to be more effective than using Claude or GPT. So this is when I'll give it some of the constraints of what I want from it. So I want it to respond in a very specific way. I'll try to avoid the how, but what I'm trying to get from it. And then also I'll give it a large voice memo. So I'll maybe record for 3 to 5 minutes on my phone. I'll then take the transcript and shove that into the context window for the system prompt and then have it provide me pros and cons of whatever the situation's about. And those are most of the points. I want to see if there are anything. Okay. So there's also a video kind of walkthrough of this blog post. So some of the authors and some of the people involved in this, they kind of interviewed each other on the topic, which was cool to watch. So I'll link that below. And I think those are all the points. All right, Internet, I hope you found this useful. So if you did, please do like and subscribe, reshare this with friends that you think they might benefit from. I have a newsletter, so you can subscribe to that in the link below. And also I have a consulting firm in relation to automating companies' internal processes with AI. So if you want some assistance with that, please do reach out. That'll be linked in the description as well. So you can book a free 15-minute discovery call with myself. And with that being said, Internet, I will see you next time.